Hey everybody, it's Mrs. Golding. I know, doesn't this look so strange? Can you believe the world we live in right now? All these people walking around in masks. This one's pretty though. It's got flowers. And a friend of mine that works at the Vigo County Public Library is leading a sewing project with people from the library, and they made it for me. The only problem is I think my my ears are deformed or too floppy because they don't want to stay on very well. I look like a little gnome or something. I'm gonna go to the grocery store later today. I have to pick up my groceries from Kroger. I did a online order. And so weird times, right? There. It's hard to judge a person's demeanor, like how they're feeling when they have those masks on. When you only see their eyes, it's hard. I saw on this YouTube video that I watch called Some Good News by the Krasinski guy from The Office. And there's a lady that made masks with that has a cutout for the mouth, but it's got clear plastic for people that are hard of hearing because many of them read lips and you can't do that. I thought that was a pretty cool thing. Anyway, let's get with some math today. I'm on Math Packet, page 16, and this is problem number 2. In this problem, it says Michelle is designing a parking lot, and she has determined that one of the angles should be 115 degrees, and that's this angle right here. What is the measure of angle X and angle Y? Okay, so we got to figure out some things about angles. First of all, if you were to just take a protractor and put it up here, I want to tell you that the answer that you get using a protractor is not going to be correct. So this picture is not completely to scale. If I put the protractor up here, it says that my angle should be 60 degrees. Why? And that's not correct, and I'm going to show you why that is in just a second. It's close. Another thing is an important tidbit from when you're going to learn how to drive. You got to park going the right direction. In other words, in a parking lot, there's arrows for a reason. And a lot of people don't heed those arrows, and it drives me nuts. The reason is because if you're coming this direction and you're going to park, that's a very natural way to turn your car. If you come this direction, which is wrong in a parking lot, and try to make that turn and park there, that's not a very natural way to do things. So even if there's not arrows, you're kind of going with the parking lot in that direction. So this one would go this way. Okay, life lesson. Yay. All right. First of all, you got to know a couple of vocab words for this problem. Adjacent angles. Adjacent angles are two angles that have a common side. In other words, this side, these two angles, this one and this one, have this side in common, which is segment BC. I guess it's a segment. It doesn't have an arrow on the end. Normally that would be a ray, correct? If they have a common side and a common vertex, and the vertex is right here where those angles meet. And so that's the vertex B. So those are adjacent. All right, next slide. If you look here, these two angles are adjacent. They have a common side and they share a vertex. These two angles right here, this one and this one, they don't have a common side. If they met up, if this guy swooshed over and met up, they would have a common side. They lack a common vertex. So they're not adjacent, but they all are called something supplementary. All right, supplementary. So I want to show you what that means in just a second. So vertical angles are what we're dealing with in this problem. They're angles that are opposite of each other when two lines cross. Okay, they're called vertical because they share the same vertex. Okay, vertical angles are congruent, which means equivalent. That means they're exactly the same. Congruent. When I come back for our next video, we'll finish up with this problem.